Good afternoon. On behalf of my team at the University of California, Berkeley, I'm pleased to present here today a project titled Artificial Relief, the first work of architectural sculptural relief produced by a generative adversarial network, or GAN. The piece was produced for display at the Italian pavilion of the 2021 Architecture Biennale. Technically, the work applies novel methods developed for the generation of 3D sculptural designs using a pseudo-3D description of form based on vector displacement maps. Conceptually, as an artistic work, the project brings tiling geometries found in contemporary architectural ornament into dialogue with forms drawn from the Western architectural canon. I'll begin with a brief discussion of the motivation for the work, and then talk about some technical processes, and then show the final piece. So the places you see here, this is where I live. This is my neighborhood in Oakland, and this is where I found myself confined in the lockdown of 2020. I spent quite a long time taking walks here, and I found myself thinking about the modernist architecture of the buildings that you see. In particular, I started thinking about those ornamental elements, such as the ones pictured on the right. In the fever dream of the pandemic, I became obsessed with these little bits of architecture, how they're expressed as deformations of stucco that hold imagistic qualities. They can look like flowers, they can look like soft-serve ice cream. These kitsch little pieces of, probably foam covered in plaster, are applied to recall some vague Western tradition, Greek, Roman, Italian, French. It's hard to tell, hardly matters. In their historicism, and in their constructed illusion of high relief, these little optical illusions in my neighborhood offer each dwelling something of an identity. Given that there's plenty of precedent for architects working in a similar sort of way, as I walked the streets of Oakland, I began to wonder if there might be an opportunity here in relationship to some machine learning work that I have been doing over the past few years. It seemed plausible to me that we might bring existing neural networks, most of which are based on raster images, to bear on generative architectural sculptural ornament. So with this inspiration, a team here at UC Berkeley and I got to work to understand if a raster representation could be adapted to describe architectural form. Since our subject matter concerned architectural ornament, initial experiments of the group examined the illusion of depth in relief. We began by experimenting with variations on our traditional depth map. We wanted to see if we could train a neural net to generate synthetic depth maps that describe interesting forms. We were also interested to know if our GAN was able to capture the, quote, form language of the test subjects shown here, a collection of synthetic Pokemon figures. This early experiment showed modest success, as we see in the two large animations, a synthetic depth map on the right and a form derived from this map on the left. From this, we surmised that an existing GAN, this is style GAN 2, could successfully learn a distinct language of 3D forms described as raster data. The depth map representation is somewhat abstracted away from the 3D geometry on which it is based, but the GAN learned it anyway, right? So the results have a sort of Pokemon look to them. That's a success. Moving forward, we quickly encountered the limits of a traditional depth map and began to look further afield to alternative raster representations. We settled on a bizarre raster representation in an obscure corner of the 3D character animation world called a, quote, vector displacement map. I'll let you read the paper to understand more about this, but suffice to say this format turns out to be a pretty good way of representing sculptural form in a way that's understandable to a neural network. With this format in hand, our team at UC Berkeley worked tirelessly to develop novel methods for representing 3D polygon meshes as 2D vector displacement maps, and for testing the applicability of existing neural network architectures to this format. In summary, given a sample form, 1, a fragment, 2, is selected and squashed onto a plane, with displacements between points in the plane and locations on the 3D mesh stored as vectors, and encoded into the RGB channels, 3, of a raster image, 4, which is a format which is both amenable to a GAN and also able to be reinterpreted as a vector displacement, 5, to reproduce similar three-dimensional sculptural forms, 6. These synthetic sculptural forms may then be combined and aggregated in various ways that are suitable for fabrication, which is exactly what we did. So that was a pretty technical account. What does it all mean? To us, the vector displacement pipeline that I just described is only valuable insofar as it opens up new subjectivities in design practice. With this in mind, we sought to substantiate that this technique holds some value in the capturing and generation of designs. This led us to develop the Artificial Relief project. From this work, we sought a historical piece that functions as a kind of starting point, an object to reconsider. For this, we returned to the ancestor, maybe the great-great-grandfather of those kitschy little sculptural stucco details found all over North Oakland. We drew samples from a specific piece in particular, shown here, the Pergamon altar. This is a Greek construction originating in modern-day Turkey, which was disassembled in the late 19th century and was reassembled in the early 20th century in a Berlin museum. The project operates in a manner that mimics the fate of the Pergamon. It begins with a disassembly of selected sculptural forms into fragments that can be described as deformations of a flat sheet. Where other machine learning processes often struggle to describe three-dimensional form, our vector displacement maps are comprehensible to the machine and serve to train a neural network to understand the form language of our selected source material. As our neural net was training, we developed certain strategies to combine, aggregate, and merge forms. Here we see one such application. The image on the left is not synthetic and instead uses a number of samples from our training set to show how vector displacement maps can be combined. On the right, two GAN-generated forms are shown, each related to a distinct latent walk. Recognizable features and symmetries appear, only to be disrupted as these twins slide apart and merge into one another. The team also began to think about how to bring these synthetic forms out into the world. Given the classical subject matter, a bronze casting seemed an appropriate possibility. To this end, we developed processes for translating the synthetic displacement maps into forms amenable to the fabrication processes that we had in mind. Here's how we proceeded. First, since a raw synthetic form shows a fairly clear and well-bounded figure, we sought to break up this reading into a simple geometric tiling that also allowed for easier aggregation. Second, accounting for material thickness and labels, an approach to arranging the pieces in aggregate is developed. Finally, recalling the rhythmic symmetry of frieze patterns in traditional Western ornament, a walk through the latent space of a GAN trained on Greco-Roman sculptural forms is aggregated across a surface in high relief. Here we see the installation as first proposed on the right. The pieces are modular, and while the position of each within the aggregate is fixed, individual orientations are adjusted in order to break down the singularity of the samples and to encourage multiple simultaneous readings of form. A quick mention of the fabrication process. We 3D printed forms on a standard SLA printer using a filament designed for investment casting. These prints were then cast in bronze using a lost wax process. And here we see some of the pieces as they arrive from the foundry prior to finishing, mounting, patina, as well as some of the highly manual processes of finishing this relatively digital work. And here, finally, we see the final piece as installed. I'll conclude with a very brief reflection. Outside of the technical processes that I've detailed above, the ambition of this piece is to evoke some suggestion of the historical material from which it is formed, some vestige of the form language inherited from the Pergamon altar in particular, while also becoming something quite different. I hope the pieces engage the viewer by hovering at the kind of uncanny boundary of individually recognizable forms and a differentiated field that suggests the latent space of the GAN itself. Thank you.